question 7 part 1, some really quite nice marks here, especially the first one. So if your diameter is 10, your radius is 5, they've got a volume and they want the height. So we're going to use the volume formula for a cylinder, pi r squared h. Put the v in, which they've given you, put the 5 in, which they've given you, and then we just need to rearrange it to get h on its own. So divide by pi, divide by 5 squared. So 450 pi, divide by pi, divide by 5 squared will give you h is 18, and you're done. Next one, quite similar really. So we've got the volume of the cones, they give us both of those. They give us that the small candle is h and the large candle is 2h in terms of height. And then they've said that the large candle has a radius which is k times larger. So if the small candle is 2, then this is 2k, and if it's 3, then it's 3k, and so on. You're just going to multiply by k basically. So we're going to use the volume of a cone. These are all on page 10, by the way. And we're going to do the small cone, we're going to do the large cone. Notice how I've put 2h for the height here, not just h because it's the large cone. And I've put kr, and that's squared because that's going to be the radius. Okay, so that's probably the tricky bit there, that kr, because you're going to square both of those things. Now, I want to eliminate everything basically except for the r's. So what I'm going to do is I'm going to square this bracket first, and then I'm going to divide this bottom line by this top line. And the reason why I'm going to divide is because a third divided by a third is 1, pi divided by pi is 1. They're all just going to go away, which I quite like the look of. So I'm going to square kr, so kr by kr is k squared r squared. Just basically square them both basically, and then divide by the small candle. It's this division here that's key. So everything cancels out. The two volumes at the start though, 150 pi divided by 12 pi, that's 25 over 2. The thirds cancel, the pi's cancel, the r's cancel, the h's cancel, everything cancels, lovely. You're just left with k squared, and you're left with 2. That 2 is from 2h there, that doesn't cancel. Divide it by 2, square root, you get 5 over 2, and you're done. Right, we'll squeeze one more thing into this part, and then we'll do a part 2. Right, so this is a sector, and it's page 9 in your log tables. It's basically this white bit that we're dealing with, but all of the formulas here work just the same. We're not working in radians, we're working in degrees, so we're going to use the bottom 2 formulas rather than the top 2. So degrees 216 is what we're given, so we're there. 8 centimetres, we're told that, so I'll just put 8 on the picture. Right, so we are asked to find r, are we? And the length as well, so we need L and R. Right, so L is just a formula, put the numbers in, push equals on the calculator, you're done. So 9.6 pi. R is a little bit more tricky. So if you get this shape, this covers a cone. If we read up here, it covers a cone. If I put my pencil under here and picked it up and joined A to B together, it would make a cone, and hopefully you can see that. So O is the point, pick it up, so that it kind of all folds down. O is the point up here, and then A and B would kind of join together. You're kind of pushing these two together and raising this bit up here to make a cone. What that makes then is it makes a full circle here, and it makes that out of the 9.6 pi that you found. Now you want to find the radius of that circle, so you know this distance around here is 9.6 pi, and you want to work out this bit basically once you've raised O in the air and made this into the circle. Well, that's just using a circle formula. So the circumference of a circle is 2 pi r. The circumference is 9.6 pi, so you're just going to divide by 2 and divide by pi. So 4.8 is the r. It's a bit tricky to kind of get to the r bit, but hopefully the L is fairly okay.